Alone, a locust is harmless. Together, they become a force of nature. Individuality becomes the price of survival. In nature, locusts exist in two phases, solitary and swarming. Most of the time, they live quietly, avoiding one another. But when the population becomes too dense, constant contact between individuals triggers the release of serotonin. Within hours, their behavior begins to change. Calm insects become restless and aggressive. Their color shifts, and they begin to move together. Soon, they gather into enormous swarms that behave like a single organism. From the ground, the swarm appears as a dark shadow stretching for kilometers. Individual identity disappears. Each locust follows the collective movement, driven by one force: hunger. Some swarms contain billions of insects. In a single day, they can consume as much food as an entire city of people. They cross deserts and oceans, traveling hundreds of kilometers without stopping. This transformation is possible because locusts can rapidly change their behavior and physiology depending on environmental conditions. In the solitary phase, they conserve energy, but in the swarm phase, their power lies in numbers, ensuring the survival of the species.
Alone, a sardine is defenseless. Together, they become a moving wall of silver. Every year along the coast of South Africa, millions of sardines form a dense column stretching for more than 100 kilometers. Their bodies reflect sunlight, creating a shimmering river that moves along the continental shelf. This migration forms a kind of superorganism, where each fish acts like a cell in a much larger body. Predators attack from every direction. Dolphins drive the shoals upward, sharks strike from below, and seabirds dive from the sky. But inside the swarm, constant movement makes it difficult to isolate a single target. When the sardines compress into tight bait balls, the swirling mass confuses predators. No single fish stands out. A lone sardine would die within seconds. Only inside the crowd does it have a chance to survive and continue the migration to spawning grounds. This survival strategy relies on synchronized behavior, reacting instantly to the movement of nearby fish. By moving as one, millions of small fish can resist far larger predators, turning weakness in numbers into the power of unity.
In a beehive, the queen does not rule. She serves. Her only task is to lay eggs. All decisions are made by the colony itself. Worker bees communicate through pheromones and the famous waggle dance, sharing information about nectar sources, nearby threats, or the need to raise a new queen. Each bee performs a specific role. Some feed the larvae, others build the honeycomb, and some guard the entrance of the hive. If one part of the colony weakens, others quickly compensate. The hive breathes, regulates temperature, and reacts to danger like a single living organism. An individual bee lives only a few weeks, but the colony can survive for decades. This survival strategy is called eusociality, a system where the individual depends completely on the group. Through division of labor and constant communication, the colony uses resources efficiently, maintains a stable temperature, and defends itself from threats, even during the coldest winters or the hottest summers.
Wolves live in a clearly organized hierarchy where every position has a specific role. At the center of the pack is the alpha pair. They guide the group and determine the strategy of the hunt. Younger wolves follow their lead, learning through experience and observation. During a hunt, wolves coordinate their actions almost silently. One wolf distracts the prey, another moves in from the side, while others wait for the right moment to begin the chase. Through this cooperation, the pack can hunt animals far larger and stronger than any single wolf.
Each member contributes to the success of the group. Strength, speed, and endurance combine into a coordinated effort that increases the chances of survival. Inside the pack, even weaker wolves receive protection and a share of the food. Injured or young members are rarely abandoned. A lone wolf faces a much harsher reality. Without the support of the pack, hunger, injury, or exhaustion often leads to death. The pack survives through social hierarchy, a system that organizes roles and shared responsibility. Experience passed from older wolves to younger ones strengthens the group over time, making the pack far more effective than any single predator could ever be.
On the ocean floor, thousands of sea stars gather into dense aggregations that can cover dozens of square meters. They move slowly across the seabed, consuming corals, mollusks, and organic remains. From above, the movement looks like a slow expansion across the ocean floor. In these clusters, individual boundaries begin to disappear. Sea stars touch one another, exchanging chemical signals and reacting to the movement of their neighbors. Such aggregations often appear during population booms or mass spawning events when resources become abundant. A single sea star is vulnerable to currents and predators, but inside the group it gains protection and access to food it might not reach alone. Sea stars survive through aggregation behavior, gathering in large numbers for synchronized reproduction and collective feeding. This strategy allows the species to increase its population and expand into new territories, even in the deep ocean. Thank you for watching. Subscribe for more.